So we're going to be going over our lab soluble and insoluble salts. And one of the things is make sure that you click virtual, which you guys already been doing. I'm going to proceed. And this lab is actually quite simple if we just understand what we have to do, right? At first we're like, oh my God, what is all of this? There's so many words everywhere. Okay. What all of this is solubility. We want to know which compounds are soluble with which. Okay. If we remember, we have cations, which is our positive ions, and we have anions, which are going to be our negative ions. And some of these react to create precipitates, and some of them do not react. And some of them are just soluble, right? So that means they create nothing. Okay, so if we look at this, it says all the solutions used in the experiment are 0.1 molar. So that means they're not that concentrated. And they're all equal in molarity. Okay, each will be in a dropper bottle, and the chemicals include the following. Sodium salts are going to be our anions. So we have our carbonates, our chlorides, our hydroxide, nitrates, phosphates, and sulfates. Then we have our nitrate salts. Those are going to be our positives. Potassium, calcium, barium, aluminum, silver, copper, iron, and lead. You'll notice that the charges are placed on each one of those. We might need those later. Okay, so now it says obtain a spot plate and make sure it's clean. We're going to clean it. We're going to add some drops of our solutions to it. It says your first spot plate is going to contain these 6 anions and these 4 cations. All right. Place your spot plate on notebook paper and label the paper. Basically wants you to make markings and say, what did you notice, right? Were the solutions clear at first, and then did they change color? Did you create a precipitate? Those kind of things. It says record the results in your report paper. Use PPT to indicate the formation of a precipitate, that is a solid. Describe the color and appearance of the precipitate, such as yellow, chunky precipitate, or white, fluffy precipitate. Or if no precipitate, enter NR for no reaction. All right, so here we go. These are our cations that we labeled, and these are going to be all the anions that are labeled on here. So I can make the screen smaller. No, all right. So we want to see what reactions occurred. So in this case, the reactions already took place, and all we have to do is make observations of the color of each precipitate. This is awesome because they're all the same. Okay. What we notice is that the potassium cations, okay, there's no precipitate with the potassium cations. So that indicates to me that the potassium cation was soluble with all of these anions. Okay, they were all soluble and there's no reaction with the potassium cation. The calcium cation produced 4 precipitates, and it produced them with the carbonate, the hydroxide, the phosphate, and the sulfate. Okay, so barium and aluminum also produce precipitates, okay, and we want to just note which ones they produced it with. Okay, so we're going to scroll down, and now it says to fill in the box based on what we saw. So we could have a table view, or you could have a list view, and you can write them down. I actually prefer the table view. Let's see if I can get it back. It's like, no table view. Dun, 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 dun. All right, now it won't go back now that I've changed it into list view. Oh, there it went. Yes, finally. All right, so this is what happens when I play around with everything, right? It changes. Okay, so when we notice with potassiums with all of these, there was no reaction. They were all soluble, okay? They all completely dissolved with the potassium cation. So we're going to put no reaction. And it was just soluble. There was nothing there, right? So it was just NR, no reaction. It was soluble. You could just write that. And you're going to do the same thing for all of these, right? No reaction, no reaction, no reaction. Then finally, we're going to go to calcium, okay? And we notice that calcium and carbonate have a precipitate that formed. So I'm going to come here and we're going to say there is a precipitate, and it is a white, chunky solid. Okay. And then you're going to do that for the rest of the ones that you see a precipitate. So you're either going to have no reaction or white chunky solids, right? All right, so once you're done with that chart describing what you see, okay, from this one, you're going to move on to your next chart. Okay. So the process is going to reappear. And then when your process reappears, it says clean the spot plate by pouring the contents carefully into a large waste beaker, rinse it, and then add the following. So we're going to add the following anions and the following cations. You notice that this time we have heavier metals as our cations. We went from like potassium to silver, copper, iron, and lead. These are heavy metals. Okay. Now we're going to go ahead and look at what we have. Now we have colors, okay? We have different things amounting here. So we have silver and carbonate, and we have some sort of pale yellow precipitate, right? If we look at copper and chlorine, we have a blue solution, okay? Silver and nitrate, we have a silver or gray solution, right? There was no solid form, so let's go ahead and do silver and nitrate on here. Here's silver and here is nitrate. You have no reaction, but you have a gray silver solution. You just want to write that down. And if you wanted to do the same for these ones, you can, where it's all a gray silver solution, you know, by all means. But the one I care about the most is going to be here, because this one is color coordinated. So you want to indicate what colors you actually have inside of your solution. Right. Once you're done, it says post-lab questions, so you're going to answer all your questions. Consider the colored precipitates you produced and the cations in those reactions. Identify the colorful cations and describe their location on the periodic table. What do they have in common? So this is going to be a little bit of research, right? So which one's your cation, A, B, C, or D? They are from the same row on the periodic table. They are from the same column. They are all nonmetals. They're transitional metals. They're all alkali metals. So figure out what all of these have in common based on the periodic table, and then choose your answer. Okay, let's go down, because all of these are just let's see. Write balanced chemical equations as indicated for any observed reaction. Write no reaction if no reaction was observed. So overall, the equation for barium nitrate and sodium carbonate. Okay, so let's go up. What do we see for barium nitrate? Barium nitrate. Okay, oops, right here. All right, so barium nitrate is just a solution. And then the other one, it's going to be reacting with sodium carbonate. Okay, so sodium carbonate. Where is that? Oh, well, we have carbonates here, right? But we don't see sodium on there. Most likely, it's sodium carbonate is also going to be a soluble solution. So we're going to be mixing those two together and figuring out if they react or don't react to create a solution, right? What we want to see actually is, do we have something mixing? Does barium carbonate mix and the sodium nitrate mix? So barium carbonate, does that create anything? Because that's a double replacement reaction. So I'm scrolling up. Here's barium, here's carbonate, and you'll notice that you will get a precipitate, a solid forming. All right, so I'm going to scroll back down. A lot of scrolling, right? Okay, so on this one, it's a double replacement reaction. Right? So what's going to happen, I wish I had a little pen here to show you guys. All right, so what's going to happen in this double replacement reaction is that your A is going to replace this C, and vice versa. So now we're going to end up with barium carbonate, and I will balance these out afterwards, plus sodium nitrate. And we have to figure out how many of each we're going to need. Okay, so let's go ahead and open up a periodic table. I mean, we could just scroll up too if we wanted to, but I like periodic tables. All right, so we're gonna go ahead and find barium now. There's barium. Okay, barium is a positive 2. Barium is a plus 2. Where are we? Here we go. So barium is a plus 2. And you notice that we needed 2 nitrates to balance out 1 barium. So that means nitrate has to be a negative 1, right? So barium's a plus 2. Nitrate is a negative 1. Sodium is a plus 1. Okay. So if sodium's a plus 1 and nitrate's a negative 1, that means that this right here is balanced and we're not going to do anything to it. Now let's look at carbonate. For carbonate, we know that sodium's a plus 1 and we needed 2 of them for 1 carbonate. So that tells me that carbonate is a negative 2. So therefore these are now balanced, right? We have a, we'll balance the equation in a second. But what we end up having is barium is a plus 2. Carbonate is a negative 2. Okay, so I'm just writing them in ion forms. Sodium is a plus 1 and nitrate is a negative 1. Okay, so these are the charges of each one of them. Okay. Now what we want, the next step is to balance the equation. If I'm balancing this equation, I have 1 barium, 1 barium, 2 nitrates, 1 nitrate. So I'm going to need a 2 here. So now I have 2 nitrates. And then I've noticed that I have 2 sodiums. Well, when I place the 2 in front of this, I now have 2 sodiums. And I have 1 carbonate and 1 carbonate. So now my equation is balanced, and I am happy with that. Okay. Can I fold that? Yeah. Okay. So equation is balanced. We're completely okay now. You don't have to do this right here, but you might want to do it on your scratch paper, your scratch notes, so that you could turn in your scratch notes. Because you'll notice that each one of these is going to ask you, okay, to turn in your files, turn in your scratch notes of what you see and what you've done. Okay. Same thing with these ones. It's going to ask you to turn in your files, right? Upload and drag your images of your spot plates. So it wants you to basically redraw these and turn those in. Okay. Now remember, the best way to figure out if something's going to react, just like we did over here in the bottom, okay, is I did my double replacement reaction and went, okay, barium is going to end up with carbonate. Does that create anything? And the answer was yes. So that's actually going to be a solid. So it's a, oh, I can make it super cool. That's going to be a solid. So, and hold it so we can see it. And sodium nitrate. Okay, so let's go up and look at all of our nitrates, see what we see in nitrates. So when I look at nitrates, I want you guys to notice something. Okay, they're different colors, right? And that color always depends on what the cation is. So you'll notice that coppers are all blues and irons are all this yellowish color, right? Leads and silvers are grays. But they all have something in common when it comes to nitrate. They don't have a solid inside of them. So there's no precipitate. So that means nitrates are soluble with our heavy metals. Okay, so they're all soluble. So scrolling back down, that means here I get to put a Q for aqueous. Okay, so we have a solid and we have aqueous. And then you could do the same thing with all of these as well. You could put a Q because it's aqueous. And over here, sodium carbonate. Well, we'd actually have to go up and look to see what sodium carbonate is. Here's carbonates. You'll notice that carbonates create solids with all of our heavy metals. and if we keep scrolling up, it creates solids with most of our non-heavy metals, right? Sodium is a +1, and you'll notice with the +1 potassium that it is soluble. So it might just be soluble, and I'm going to go with soluble. There is a way to verify it, and we're going to go ahead and do that right now too, just to make sure we're giving it the correct phase here. So we're just going to look at a solubility chart. So solubility chart. All right, and we're looking for sodium. Which ions are soluble? And in this case, it says alkali metal. So everything in group 1. So those that make the +1 charge are all soluble. So sodium, potassium, lithium. They're all soluble in everything. So we are correct. Okay, our assumption here was correct. And this first one is done. So just remember, make sure to look at them and go, okay, what kind of reaction I'm gonna have. All of these are double replacement reactions. So you're gonna end up with a barium carbonate and all of these, right, that have barium. So make sure you're doing a proper double replacement reaction. All right, you guys, I hope this video helps. Ciao.